Okay, now for polar example 12. This one's going to be a little bit, well, it's not too bad. It's a little more difficult. It says find the area of the region that lies outside the circle r equals sine theta and inside the circle r equals 2 sine theta. Do a little sketch. R equals sine theta has a radius of 1, so it's just going to be a little circle here. 2 sine of theta has a radius of 2. Okay. And I want outside the small circle, inside this large circle, so I want this area. So essentially, I just need to do 1/2 the integral of the outside squared and subtract away the inside squared d theta. And all I need to know is, my outside is my big one, which is 2 sine theta. The inside is the smaller one, which is sine theta. So I really just need my limits. Well, how long does it take to graph the whole circle? How long does it take to get from here all the way back around? In a circle, let's see, which one do we want to graph? Let's graph the big one, because it's going to be the same regardless, because all the 2 does is determine the radius, or actually the diameter of the circle in a polar. So 0. Sine of 0 is 0, times 2 is 0. So it starts out 0, 0. So that's my first point here. Pi over 2, sine of pi over 2 is 1, times 2 is 2. So it graphs this entire thing from 0 to 2 to pi over 2, and it's here. Pi is back to 0, and then it comes back. So it only takes from 0 to pi to get all the way around either one of your circles. So it's simply 1/2 0 to pi 2 sine of theta squared minus sine of theta squared d theta. And I'll just trust that you can type that in your calculator on your own. I'm not going to take the time to do that again, because setting it up is the hardest part. I feel like typing it in your calculator is the easy part.